big spoiler alert, I've given you the result at the beginning of this video, so I suppose if you don't want to know the proof, you can just know that ln x differentiates to 1 over x. The first thing that you do is you take the limit of ln x, where h goes to 0. So ln x would become ln x plus h minus ln x all divided by h. This is how to find the limit of ln x, and also how you would find the limit of a lot of different functions, but we're not going to do that now. You now use a very popular and well-known identity, which is ln a minus ln b would be ln a over b. You know, because it's subtracted, whatever is inside the brackets is then put into a division to simplify it. So we can now apply this. Obviously, this minus this would then be the limit where h goes to 0 would be ln x plus h over x all divided by h, which would be simplified as when the limit of h goes to 0, you would get ln 1 plus h over x all divided by h. Now we can sub in for u equals h over x, or if we rearrange this, h equals ux, as h goes to 0 and u goes to 0. So if we have the limit of u going to 0, we need to now substitute in all of our values of h where it contains a u value. So we have h over x, which we know to be u, so it can be ln 1 plus u, but we have this h in the bottom here that can be substituted in for this, which is ux. So now we've changed the whole function from x's and h's to u and x's. So we can now pull out this 1 over x term. If you think about it, there is a hidden 1 here. So this would come out, and you would have ln 1 plus u all over u. Now, we're going to use the Taylor series expansion, where we know that ln 1 plus u equals u minus u squared over 2 plus u cubed over 3 minus u4 over 4 plus, and so on. Taylor series is the negative and positive alternate, and the indices go up by 1 and you divide it by it. It's not a Taylor series video, so I'm not going to explore that completely. But anyway, now the next thing that you do is divide both of the sides by u. So now if I divide this by u, this by u, that would then become 1. This would become u over 2. That would become squared. That would become 3. But now, as I've divided it by u, what a coincidence. This looks like this, doesn't it? And we know that 1 minus u over 2 plus u squared over 3 minus u cubed over 4 is the same as that. But now if we take the limit of u going to 0, this whole expansion would equal 1. So if this equals 1, we can now plug this into here, and what do we get? We get d dx ln x equals 1 over x multiplied by 1, which is 1 over x. I did it. The reason I did it is because I'm better at you at maths. I'm better than you at maths. Like, that's why I can do it. The reason you're watching this video and I'm recording this video is because I can do this. Huge flex, huge party trick, something that you can do at any point in your life to impress anyone. I hope this has been useful to 3 or 4 people.